So we have integral. And say inside of integral, we have two boxes, right? And say we have variable dx. When we have two of them, or when they look at more complicated one, and pick inside part of it. Inside part of it is going to be u. Okay? That's kind of our rule of thumb, how we're going to be choosing doing the substitution. Okay, and usually if you have expression with parentheses, that might be a good candidate for you. Right? Usually if you have parentheses, whatever expression you have in parentheses, that might be a good candidate for you. Okay, so that's how we choose what u is. Sometimes we have more than one choice, so we'll have to try to do maybe more than one. And then we're going to do 3 lines, right? First one, we need to say what u is. Then we need to find du. Remember that is derivative times dx. And then we solve for dx, which is going to be du divided by that. Right. Then we do substitution. Sub into integral. Into integral. Then we do algebra arithmetic. So then we're going to get integral on u only. So we'll do algebra, maybe something else. We need to get integral only on u. So we don't want to have any x's, t's, y's left. So then we integrate. So we're going to get expression in terms of u. Okay, a plus c. And then do back substitution. So that's an outline how we're going to be doing substitution, right? So let me illustrate that on a couple of examples. X times 3 plus 2x squared dx. So I see more complicated part. I see inside part of it, 3 plus 2x squared. And that's what I will try to be my u. Then I find du. Derivative 2x squared is 4x. Then find dx. U over 4x. And then we finish. Integral x square root of u du over 4x. Do algebra to reduce x on top and x on the bottom. Visualize that we have 1/4, which is a constant. Constant can be pushed outside of integral. Integral u to 1/2 du. So that means our substitution did go smoothly. And now we are ready to finish it up. 1/4 u to 3/2 multiplied by reciprocal of the power. So new power 1 more, 1/2 plus 1 is 3/2 multiplied by reciprocal of 3/2 2/3 plus c. So we're done with integral. All that is left, just do back substitution. Maybe reduce that expression a little bit. So we're going to get 1/6 square root of 3 plus 2x squared cubed plus c. So we have integral of x squared divided by x cubed minus 3 divided by 2 dx. So choose what u is supposed to be. Find du, find dx, do substitution, and try to proceed. Okay, so I'm going to give you a couple minutes to do that. So give it a try. Okay, let me try to catch up on you. I look at the integral, I see parentheses, and I have expression parentheses x cubed minus 3. So that's maybe a good candidate to be u, x cubed minus 3. Then 3x squared dx is going to be du. And then dx is going to be du divided by that coefficient 3x squared dx. And now I'm ready to do substitution. So we're going to get integral x squared u squared, and instead of dx, I'm going to write du over 3x squared. So that's the substitution I'm trying. Now I'll do algebra and I'll reduce that expression a little bit. So I cancel x squared and x squared. So I'm going to get 1/3 is a constant, I can push it outside. U squared on the bottom, so it means u to the negative 2. And that should be easy enough integral. So we're going to get u to the negative 1 over negative 1 plus c. So we're going to get negative 1 over 3u plus c. And don't forget to do back substitution. So don't forget to do back substitution. Recall what u is. So final answer is going to be negative 1 over 3 times x cubed minus 3 plus. Right from beginning, I see parentheses x, we see expression parentheses 3x, and u equals to 3x. It's supposed to be easy substitution, so make sure that you're comfortable with easy substitution, like u equals 2x, 3x plus 1, 2x plus 7, okay? So I will do that immediately. So du equals 3 dx, so dx equals du over 3. So it's easy enough substitution. So the substitution u equals, again, 3x, or similar to it, 2x, 5x, 7x, 10x, easy to do. So make sure that you're comfortable doing that. So we're going to get sine squared u cosine u du over 3. Take 1/3 outside. So we're going to get sine squared u cosine u du. Okay. So our substitution did go successfully because we got integral on u only. It's still complicated integral, but if you look at the original integral, and if you look at the one which we got now, that is a simpler integral. And as long as we're getting simpler integral, as long as we're getting something easy and easy to deal with, we're on the right track, okay? So even though substitution u equals 3x didn't go give us immediately the answer, it led us to get rid of those pesky 3x's, which maybe, sometimes in our way, okay? So we got simpler one. So we're not done with it. So what we'll do one more substitution. And in this case, I cannot double dip, I cannot use u twice, so I will use, we have 26 letters to work with. So, and if it's not enough, we'll switch to Greek letters. So anyhow, u is taken, x is taken, so I will use, say, w. Now I will use new variable w, then I find dw, and I will solve for du. Now let's figure out what should be the w. See my expression. I have sine squared and cosine u. Sine is confusing as cosine. Sine squared, therefore, will be more confusing than cosine. That's more difficult. So I have sine u, I'll look at this, squared. So my possibilities for substitution is going to be either to choose the whole thing, W will be the whole thing, or better, just inside part of it. Okay? So that it will be the better one. So you can always try to do the big one, but if you see the smaller one, try to pick a smaller version. Try to pick smaller part of it. So in this case, it's sine u. So that's the one we'll try to progress with. Sine u, derivative of sine is cosine. Du, so du equals w sine u. Probably have to be careful when I write in w's, right? So my w somehow looks awfully similar to u. Okay, so don't forget that 1/3 integral. Sine squared u, we can write it as a sine of u squared. So we're going to get w squared cosine u. Du is the w over cosine u. So in this case, cosine and cosine cancels out. So we have 1/3 integral w squared dw. And that is easy enough integral now. So we should be able to finish it. So I'm going to put those here. Do back substitution. And make sure that you actually will do back substitution twice. You go from w to u, from u to x. Back substitution twice. So I skipped a couple steps here. I believe the final answer will be sine of 3x cubed over 9. Okay. And I guess a comment here which I want to make. Comment. We didn't have to do the whole 2 substitutions. So we might have done the whole problem at once. If we did, we might have done one sub u equals to sine of 3x. So if you see one big substitution which works, it works. But I'll suggest do simpler versions, do easy substitutions. Yeah, u equals to 3x. And then proceed with what you have to do. Okay. So we have integral 0 to 1 x over square root of 1 minus x squared dx. So certainly we see substitution which we want to do here. U equals 1 minus x squared. Du equals negative 2x dx. So dx equals u or negative 2x. Both are the same 3 lines which we did already a few times yesterday and a few times today. For definite integral, we're also going to put one more line. So our original limits for x goes from 0 to 1. That implies u, which equals to 1 minus x squared, is going to be changing. So on the bottom, we're going to write down what will be happening with u when x equals to 0. So when x equals to 0, That's x equals to 0, and we're going to put it here. So when x equals to 0, u is going to be equal to 1 minus 0 squared, so it's going to be 1. On top, we're going to substitute x equals to 1. And we're going to calculate corresponding value of u. U equals to 1 minus 1 squared, so it's going to be 0. So limits for u is going to be changing from 1 to 0. So my new integral is going to look like u equals to 1 on top, u equals to 0 on the bottom. Limits of integration, now in terms of u, x square root of u divided by negative 2x. So for definite integral, that's kind of new part, right? We're also going to take care of those limits, because we also have to do substitution for limits. Then x and x cancels out. And we are ready to write our integral. So negative 1/2, u equals to 1, u equals to 0, u to 1/2 du. And that's the easy integral. And substitution did go successfully, because now we have, if you look at the integral, there are no traces of x or y or s. So all the information is, everything is written in terms of u. So our substitution did go smoothly in this case. Okay, let me quickly fill up what I expected you to do. So u equals 5 plus t squared 2t dt du divided by 2t. So u is changing from 5 to 9. So substituting, u is changing from 5 to 9. T square root of u du divided by 2t. So 1/2 u equals to 5, u equals to 9, u to negative 1/2 du. Okay, so after substitution, the integral which we are looking for is something like that. And then it's easy enough integral to work with. So 1/2. Antiderivative u to the negative 1/2 is u to 1/2 multiplied by reciprocal from 5 to 9. So we're going to get square root of u after cancellations from 5. So final answer for this problem now, substitute upper bound, substitute lower bound. So I'm going to get 3 minus square root. Find the area. Of the region. Bounded off by y sine x 1 minus cosine x squared below by y equals to 0, sides by x equals to 0, x equals to pi. So we have a region which is bounded above by that function sine x times 1 minus cosine x squared, below by y equals to 0, on side by x equals to 0, x equals to pi. Okay, so I'm not sure how exactly it's going to look like. We want to give best. Let's try, I guess. So we have x equals to 0, x equals to y. And our curve is going to look something like this. Correct? And we're looking for this region. You can get better idea how the curve look like using a graphing calculator, but for our purposes, that's good enough. What I realize is the following: y equals sine x 1 minus cosine x squared is greater or equal than 0 on interval x is between 0 and pi. And that's what I sketched right here. Something positive. I'm not even concerned about the shape. On the bottom, I put y equals to 0. On the sides, I have x equals to 0, x equals to pi. And the area of this region is going to be integral from 0 to pi, function y dx. Okay? Because if the curve is above x-axis, then area of a region bounded by that curve above is going to be equal to integral. That's what I'm concerned with. Okay. Recall, if we have positive function on interval from a to b, and we are looking for this part, and this area equals to integral from a to b y dx. Okay. So that's exactly what we do. So in our case, we have from 0 to pi. And in our case, we have function y equals sine x 1 minus cosine of x squared. So in our case, area equals integral 0 to pi. Because we said from 0 to pi, function sine x 1 minus cosine x squared dx. And now that is definite integral. We'll do substitution. See parentheses. So we find du, we find dx, and because we're working with definite integral, also find limits of integration for u. Okay. So I'm going to give you a minute or two to try to work on it. So derivative of cosine is negative sign. Derivative of negative cosine will be positive sign. So sine x dx. So du divided by sine x equals to dx. Okay. X is changing from 0 to pi. Therefore, u, which equals to 1 minus cosine x, is going to be changing from 1 minus cosine 0 on the bottom to 1 minus cosine of pi on top. Right? Cosine of 0 is 1, so 1 minus 1 is 0. Cosine of pi is minus 1, 1 minus minus 1 is 2. So limits for u is going to be from 0 to 2. we're going to get integral u equals to 0, u equals to 2 on top, sine x, u squared, u or sine x. Sine x will be cancelled out. So we get integral u equals to 0, u equals to 2, u squared du. So we're going to get u cubed over 3 from 0 to 2. So we're going to get 8 thirds as a final answer.